So evaluating algebraic expressions. We've done a lot of evaluating at this point, but we're just going to do it a little bit more with some more formulas. Evaluating is very simple. It's basically just two steps. Substitute all your variables in and then do order of operations. That's all you're going to do when you're evaluating. You are going to substitute in every variable for what they have told you the variable is, and then you are just going to do order of operations. So it's very, very important that if you do not know order of operations as well as you should, you start really honing in on this because you're going to use it here when you evaluate. All right, the first example that they give us here in example 1, it says evaluate 3a squared minus b plus c cubed when a is 1, b is 4, and c is 3. So our first step is just to plug it in. And I will say that you have to be very careful that you don't leave pieces out because sometimes people forget to add or subtract at the end. You also want to make sure that when you plug something into a variable that you do everything to that variable. They gave us all positive numbers here, but sometimes negative numbers can be confusing when you're doing exponents. So make sure if you need to that you put those things in parentheses. All right, so the first thing we're going to do is we're going to plug it in. It says 3, and instead of a, we're going to write what a is. A is 1, 3a squared, minus b, and instead of b, we're going to write 4, and then plus c cubed, and instead of c, we're going to write 3. Now, you don't have to necessarily put those in parentheses. I am just doing that so you can see where your variables were. Order of operations says to do grouping. We technically do not have any grouping. I put it in parentheses, but that's not a grouping. Grouping is when you have some type of operation inside the parentheses. So since we have no grouping, we're going to do our exponents. Our exponent here, 1 squared, 1 to any power is just 1. So that's 3 times 1. Minus 4, we don't do anything with that. And then this 3 cubed is what? 27. All right, my only multiplication here is really just the multiplication times 1. So I have 3 times 1, which is 3. 3 minus 4 plus 27. Now I'm going to do addition subtraction from left to right. What's 3 minus 4? Negative 1 plus 27. 26. All right. And that would be my final answer there. So when it wants me to evaluate and it tells me what I'm plugging in, plug it in order of operations. All right. Let's do one that's a little more difficult. Look at example 2. Example 2 says x squared times y times z squared. And then they were nice and they gave us fractions and negative numbers here. Fractions and negative numbers. All right, let's look at this. This is where it's kind of important to put parentheses because of that negative. That negative can throw you off. And so if I'm plugging in for this one, x squared, well, I'm going to write negative 1/2, and that whole thing is squared. All right? And then times y. Well, y is negative 2. And then z squared, and z is 1/4. All right? And so this is where you need to pay attention to your negatives, all right? When you're plugging something in, you have to do whatever the operation is to the whole thing. So if I have negative 1/2 and I square it, what is negative 1/2 times negative 1/2? That's addition, multiplication, right? Negative 1/2 times negative 1/2. Yeah, it's positive 1/4, right? We have a negative times a negative, which is positive, and then 1 times 1 over 2 times 2. We'll multiply that by the negative 2. Let's go ahead and do our other. What is 1/4 if I square it? 1/4 times 1/4? 1/16. All right, 1/16. All right, and now that I have that, I can just multiply. Now, if you have a whole number thrown in here, that's okay. Just remember that you can rewrite that to over 1 if that makes it easier for you to do your multiplication. And also remember you can cross cancel. Okay, you can cross cancel because it's all multiplication. All right, so I can cross cancel here to make it easier. The 2 can cross cancel with either the 4 or the 16. It actually does not matter which one you cross cancel with. All right, so either way it's going to be a 1. If I do it here, that'll be an 8. If I do it over there, it would have been a 2. And then I can just multiply across. If this is all multiplication, I can multiply all my numerators across and all my denominators across, okay? All right, so now I can just multiply across. 1 times -1 is -1, times +1 is still -1. And then 4 times 1 is 4. 4 times 8 is 32. And so my answer here would be -1 over 32. -1 over 32. So formulas you are going to see mostly in things like science. You'll see a lot of formulas in math, especially in geometry, and those are the ones that they're about to give us, are geometric formulas. But in science, you're going to see it all the time. So you're going to see formulas in chemistry, lots of formulas. In physics, lots of formulas. All right, and so a formula is an equation that expresses the relationship between related quantities. All right, between related quantities. All right, that's what a formula does. So we have this example. When preparing for her youth group's mission trip, Sarah found that the average daily temperature in Spain during the visit is 25 degrees Celsius. We don't use Celsius typically over here, right? And so she used the formula F, or Fahrenheit, equals 9/5 Celsius plus 32. So this is the formula to convert from Celsius to Fahrenheit. This is your formula, so you do want to know that one. All right? 9/5 Celsius plus 32 is Fahrenheit. So she wanted to figure out if the average temperature right now this time of year is 25 degrees Celsius, what does that mean to me? And so she's going to plug it into the formula. The 25 represents the C in this formula. So we are going to do exactly what we did on the previous example. To find the Fahrenheit, we're going to say 9/5 times the 25. And then we will add the 32. All right? And so we are going to do order of operations. We're going to do our multiplication. Remember, this is 9/5 times 25 over 1. What can I do with these fractions here? Yeah, I can cross cancel. This is a 1. This is a 5. So 9 times 5 is what? 45. And then I add 32. So what is the average temperature in Fahrenheit there? 77 degrees. And this is something that she can relate to, right? If she's not used to using Celsius, then 77 degrees Fahrenheit is something that's more familiar to her. And so she's going to use this formula to do it, right? So this is one type of formula. And this is often used. And you'll see this in science too if you have not already, converting Fahrenheit to Celsius and vice versa. And when we do some solving of equations, you can actually find either one when you have these things, all right? Let's look at some common formulas. All right, let's look at some common formulas. If you do not already know these, you want to learn them, okay? You'll want to learn them. You'll actually need to know them next year too. Perimeter is very, very simple. Perimeter is just the distance around, all right? There are some special ones though. So for a rectangle, the perimeter is 2L plus 2W. The L is for length, the W is for width. The reason is because both sides of the rectangle are the same length. So your length and your length are going to be the same, your width and your width. It's not going to be skewed in any way. And so with a rectangle, you're going to have 2 of one measurement and 2 of another. That's how a rectangle works. So your perimeter for that is 2 times the length plus 2 times the width. The square is also the distance around, but every side of a square is the same exact length. So instead of saying side plus side plus side plus side, we just say 4 times the side length because that's what it is. It's just adding the side length up 4 times. Your circle is a special one. 2 times pi times r. And in this room particular, we're going to use pi as 3.14. So we are going to round pi to a decimal, and we're going to round it to the decimal 3.14. In the Bible, they rounded it to 3. We now know that it goes on forever, so we have calculators that give you the actual pi or as far as it can go. And so your calculators will round further. We're just going to round it to 3.14. So that's what we're always going to use in this room if we use pi. And then triangle a plus b plus c, that just means add up your side lengths of your triangle. So those are your perimeter formulas. Your formulas are 2 times the length plus 2 times the width. That's your rectangle. Square, you just multiply your side 4 times. Circle 2 pi r, and triangle, just add up all your sides. All right, that is perimeter. So perimeter means the distance around. So perimeter is going to be used like if I were to put trim work up in a room, that's perimeter, okay? If I were to put a fence around my yard, that is perimeter, okay? If I were to frame something, like framing of a picture, the frame would be perimeter. Those are all examples of distance around, all right? The second set of formulas here is area. Area is all the distance inside of the figure. So for like a wall, it's if I were to paint the wall, that paint is the area. For a floor, if I were to carpet the floor, the carpet represents the area, okay? If I were to fence my yard, the fence would be the perimeter, but the grass inside would be the area of the yard. So it's everything that covers up the surface of the figure. That is area. For a rectangle, you just multiply your 2 dimensions. You multiply your length times your width, and you will get the area inside. For a square, you do exactly the same thing. You multiply your side times your side, but because they're the same, you're going to see side squared because they are the same length, side times side. The circle is special. Pi times r squared. R here is my radius. What does it mean by radius? What's the radius of a circle? Right, so half the distance across. So it's from the center to the side. That is my radius. From the center to the side. So the same number that you use for the circumference of the circle or for the perimeter around it, you're going to square it for this one. So instead of 2 times pi times r, you're going to say pi times r squared. Pi times r times r. All right? And then the triangle is kind of a special one too. It looks similar to your rectangle, your 2 dimensions, but then you cut it in half. So 1/2 times your base times your height. And the reason for that is because you can basically cut a square in half and you get your triangle. All right? So those are your formulas. Let's look at using them. Example 3. It says, find the perimeter of a rectangle whose length is 8 and whose width is 3. So they have given me the L and the W, and they want me to find the perimeter. So what I'm going to do is I'm going to plug it in. My formula is 2 times L plus 2 times W. So I'm going to take this 8, and I'm going to plug it in for L. And then I'm going to take this 3, and I'm going to plug it in for W. And then I am just going to do order of operations. My multiplication first. What is 2 times 8? 16. And then my 2 times 3. And so now I can find out that my perimeter is 22. They specifically said centimeters. So I'm going to say 22 centimeters is my perimeter. 22 centimeters is my perimeter. In your books, example 4. Example 4. Find the area of a circle with a radius of 9 feet. All right, so my area then of my circle is going to be pi times r squared. Pi times r squared. All right, they have given me the radius. They said the radius here is 9. So I'm going to say pi times 9 squared. Pi times 9 squared. All right, I'm going to do this first. What is 9 squared? 81. So I have 81 times pi. Now, this is sometimes how you'll see your answers, okay? If I say leave pi in your answer, then this would actually be your answer right here. 81 pi would be your answer. So if it says leave pi in your answer, then I don't want you to multiply it out. If it says round, all right, in this case, they rounded to the nearest 100th place. If it says round, then it means it wants you to actually do this whole process here. 81 times 3.14. Typically, because you're not using calculators right now, I am going to have you leave your answers just like this. That is typically how I'm going to have you leave your answers, okay? In the book, it goes on and it actually multiplies this out with decimals, and it gives you this pretty big number. What I do want to point out is that it is feet squared. So, while you have 81 pi here, it is feet squared. The reason it is squared is because we're talking about area. And so what you actually did is you multiplied 9 feet times 9 feet. And when you multiply a unit times a unit, you get a unit squared. So that's why your area will always show squared, all right? It is two-dimensional that you are measuring, and so you're giving both dimensions there with the squared, all right? Questions on the formulas or just plugging it in? All right, so I want you to try a couple of these. We're going to look at the steps to finding a formula real quick, and then we're going to talk about doing it. So, using formulas. First and foremost, use the right one, okay? So, use the correct formula. This seems like, yes, of course, that's what you do. But if it says perimeter, or if it says find the length of the fence, like you have to know whether you're finding perimeter or whether you're finding area, okay? So first of all, make sure you're using the right formula. Make sure that you're using the right figure, rectangle, square, circle, triangle, and then make sure you're finding the right one, perimeter or area. Then you're just plugging in the values they give you and using order of operations, okay? So once you figure out what formula you're using, you're just plugging it in and using order of operations to do it, okay? So make sure you know these 4 little formulas here that they have given you. That's something you need to know, those 4 formulas. All right, and now I want you to try some on your own. All right, let's look at these together. Convert 8 degrees Celsius to Fahrenheit. So I'm going to use the same formula that we did at the beginning. We're going to say F, the Fahrenheit is going to equal what? 9/5 times your Celsius plus what? 32. All right. All right. Once we've done that, we will do our multiplication. So you have 9/5 times 8/1. All right. What does this equal? 9 times 8 is 72/5 plus 32. All right. You can do a couple things here. You can convert if you want to and do a mixed number plus your 32. And then you can just have the fraction there. So if you don't want to multiply this big guy by 5, you can multiply this one or just change them to a mixed number. So 5 goes into 72 how many times, by the way? 14 2/5 plus 32. And you can do it that way if you want to. And you get 46 2/5 or 46.4. Or you can change this one to over 5. And that just gives you a lot bigger numbers though. So if you do 32 and multiply it by 5, you're going to get 160 over 5. that's going to be much bigger to add and then change to a mixed number. Because you don't want to leave your degrees as an improper fraction. So for most cases, I would say an improper fraction is fine. But for degrees, you wouldn't want to say, some crazy number over 5 degrees, because that just doesn't make sense. So 46.4 degrees. If I were to tell you to round it, you would say 46 degrees there. All right, let's look at 14. A picture that is 11 by 14 is to be framed using wood that is 1 inch wide. Find the perimeter of the picture and then explain why the length of the perimeter would not be enough to frame the picture. Okay, so for the perimeter, so they've actually said here perimeter, but if they just said find the amount of frame, you need to pay attention to the fact that they're framing the outside, and that is perimeter. All right, so if they have done 11 by 14, they want the perimeter of the picture itself. So how do we find this? 11 is length, hopefully. 14 is width, or vice versa. It doesn't matter. But we do need to know the perimeter of a rectangle. We do need to know this one right here. And so we're going to plug in 2 times 11 plus 2 times 14. All right, order of operations. 2 times 11 is 22. 2 times 14 is, yep, and so 22 and 28 give me 50 inches. All right, they're saying why, if I got that exact perimeter as a frame, why would that not be good? What's going to happen if I do the exact perimeter with a 1 inch wide? Well, and on top of that, it's an inch wide. So if it's exactly that much, it's going to take up an inch of your picture, right? So very often you want to make sure your picture is a little bit smaller than your frame, or else you cover up part of your picture. Depends on how you centered your picture, but. All right, let's look at the last one. Volume can be found, and they gave you the formula here. So this is not one that you need to know, but they did give it to you in the actual problem itself. The volume of the box, and they gave you the length and the width and the height, and then they want you to find it. So here you're just going to plug it into what they told you. You're going to say length, that's 4 inches, times width, that's 2 inches, times height, that's 5 inches. And then you can just multiply straight across. 4 times 2 is 8, times 5 gives you 40. Now, how many times did I multiply inches? 3. So I'm going to say inches cubed here. I multiplied inches times inches times inches. My dimension should be cubed. Whereas here, I actually didn't multiply anything by itself as far as units, right? I multiplied 2 times 11 inches and 2 times 14 inches, but then I added. So that's why I don't have inches squared there. I didn't ever multiply inches by inches, all right? If that had been area, it would have been squared. Volume, that's going to be cubed because you multiplied it 3 times by itself.